Right. Good morning, everyone. Right. So, friends, in the last class, we have seen this example of one problem wherein we try to predict the weight. Right. So, I'll quickly try to give a recap of this example. This is very important example. Right. So, what we are trying to do is we are trying to define a machine learning model. What is called as model? Machine learning model. Right. So friends, let us take an example. Suppose I have two variables, one is called as height, another one is called as weight. Let us assume that these are the correct values which I got it from a doctor or some from reliable source. So if height is 4 feet, weight should be 52 kg, like that I got some data. Now what I am trying to do is, in order to create a machine learning model, what I am trying to do is I will create a machine learning model such that if you give the height, if you say the height is 6.11 feet, then my program will tell what should be the ideal weight. So if you want to know the weight of a given height value, my program will predict. So that is called as machine learning model. It's a very simple example. More complex examples will come in future, but this is a very simple example wherein weight will be predicted for a given height. What should be the weight? The machine learning model will tell. Now comes the question, sir, how a machine learning model will come to know what should be the weight for a given height? How do you train the machine learning model? So some important terminology we have used in the last class, friends. Right? We have also seen how machine learning is different from conventional programming. In machine learning, we have the data, we have the expected outputs, both will be given to the model, and both will be given to the computer, right? And we create a model, right? So if you recollect, right, this is this slide. This slide is very important, my dear friends. So data, output. This is what happens in machine learning. This is your normal programming. Data and program will be given to computer. Computer will generate the output. In machine learning, data and output are fed to the computer. Computer generates the model. Computer generates the program. So we have to understand this difference. We have to understand that machine learning is different from normal programming, and we have to try to understand how this actually works. So this second diagram is very important, right? It explains you how what exactly is machine learning, right? So coming back to this example, friends, see here. So what we will do is, here height is called as independent variable. In this example, height is independent variable. Height is independent variable. Weight depends on height, so weight is a dependent variable. Now what we are trying to do is, how we create a machine learning model means, we will try to understand the relationship between dependent variable and independent variable. See here, we are trying to plot it. If I try to draw a graph based on that data, this is height 4, weight should be 52. Height 4.2 feet, weight should be 56. Like that, if I try to observe this, what I am getting is, I am getting two lines, right? And if I try to study the relationship between these 2 points, data points, what I can do is, I can apply a function called as y equal to mx plus c, right? So I'm using one more word, friends, another important word. So these are the fundamentals of machine learning. The terminology which we are using now, they are the fundamentals, and everyone should understand that fundamental terminology. So training model, is one word. Training is another word. Function is another word. So these are three important words, my dear friends. If you don't understand these words, you will not understand the subject. If you don't understand these words, please let me know. Right? So if you don't understand these words, please inform me. Please let me know. Right? So these are the three important words. One, two, three. So one is model, machine learning model, right? Model means the program which we are going to learn, the program which is going to learn from the experience, the program which is going to learn from the data which you are giving. So what I am doing is, in this example, how do I create a machine learning model means I have certain data with me. Please observe this. 1, 2, 3, 4. I have 10 data items. 10 data items, heights and corresponding weights. So I have 10 data items. This information, this data along with its output, if height is 4, weight must be 52. If height is 4.2, weight must be 56. Like this, I am teaching, I am training my program. I am training my program. So this training means what we do is the data as well as output, whatever block diagram we have seen, right? We are training the model by giving this height and weights information. So what I'll do is I will try to study the relationship between these two variables. Height is an independent variable, weight is a dependent variable. I am trying to study the relationship between height and weight. I know that weight depends on height, but how much proportion of change, right? If I change the height, let us say from 4 to 4.2, I have modified. Whenever I change the value of height, how it is affecting the weight variable. That proportionate change, if I can study, then I can predict also. So what we are doing, we, since it's a simple line, I am applying equation of line formula. Please remember, every machine learning model needs a function. Every machine learning model needs a function. This function is also called as learning function, or some people call it as training function. Right? Some mathematical function will be there. So in this example, what I will do is I will use this y equal to mx plus c as my function. Here y is weight, which is a dependent variable, and x is my height, which is independent variable. Now for example, let us take the first combination, 4 and 52. So I have the output as well as input. I know very well, like weight should be 52, weight will be 52 when the height is 4, right? Let us assume c is some constant, let us fix it to 2, 3, some value like that. So that portion will come into picture. Now m of 4. Similarly, when weight is height is 4.2, when height is 4.2, then the weight should be 56. Like that, in every case, I am able to find the value of m. Here m is called as a slope. I hope you might have studied it in basic mathematics, my dear friends. So m is the slope. Slope means, what is the definition of slope? It determines the proportionate change. Whenever I make some changes in independent variable, how much change is seen in the dependent variable. That variation, that proportionate change is defined by m. So m is very, very important. Now what I will do, since I have 10 datas along with outputs, in all these 10 cases I will try to study how the m is behaving. With this, I will come to know what will be the value of m, how m is getting changed. So accordingly, what will happen after getting training? This is called as training now. So I have first combination, second combination, third combination. My program is learning. When height is 4, weight should be 52. When height is 4, weight should be 52. When height is 4.2, weight should be 56. When height is 4.5, weight should be 57. Like this, I have 10 combinations. My program is learning from 10 different combinations. Now it will study the value of m in all these 10 cases. It will try to find a most appropriate and most accurate m value. And once that m value is known, what I can do is I can predict now. You will ask me, my program will tell you, you will ask me, my program, you will say if the height is 6.11 feet, what should be the weight? So my program will apply this, y is equal to mx plus c. M value, whatever it has calculated, x value is 6.11, right, plus constant. So whatever m value it has calculated, whatever m value it has noticed, it will try to use that m value and it will try to predict what should be the weight if the height is 6.11. So like this, I can create a machine learning model. I can create a machine learning model. When my program can predict the weight for a given height, then it is called as model. I repeat, when my program can predict the weight for a given height, then my program is called as machine learning model. Training, what is training? For my program, I gave some knowledge, these are the 10 data items. If height is 4.11, weight should be 60. Like that, whatever knowledge I am giving to my program, that is called as training. And in order to perform prediction, right, my model should learn. This is called as learning function. Between output variable and input variables, there should be some relationship, and that relationship must be studied. For that, we need a mathematical function which is called as learning function. So these are fundamental points, my dear friends. So model, training, learning function. You will find learning function in every problem which we are going to see in future. Complexity of the learning function may vary, but there will be a learning function. So output will be a machine learning model, right? We use mathematical function, we train the model, and finally we will get a model. To what extent this model is working properly, that we will see again. That is accuracy part. We will come back to that. So till now, these are the three important words which I wanted to introduce. Is it clear? Till now, is it clear to everyone? Please let me know in the chat box. Please respond. Please let me know in the chat box. Till now, things are clear to everyone. That's great. Fine. Now let us come back to our. So yesterday we have defined this, right? What is machine learning? Definition of learning we have seen, right? So there are three important things in the definition, sir. One is E, one is T, another one is P. A computer program is said to learn from experience with respect to some class of tasks T and performance measure P, right? So here this performance will improve over a period of time, means with experience the performance will improve. With experience the performance will improve, right? So we will come back shortly, right, after discussing couple of other examples on well posed learning problems. We will again go back to that Excel sheet and we will try to discuss what is performance and how exactly the performance measurement is done and what are the various methods of performance measurement that we will see in our future units. But what is performance, that we will define today by going back to our previous example. Before that, we will see few examples, right? Now this is your topic from the syllabus. Definition we have seen, and the next topic is well posed learning problems. Well posed. A learning problem is said to be well posed if there exists a unique solution. Remember this. If there exists a unique solution, then it is called as well posed learning problem, right? And solutions behavior changes continuously with the initial conditions. Solutions behavior changes continuously with the initial conditions. Please keep this point in mind. Very quickly we will come back to this point also. What do you mean by initial condition, right? What do you mean by initial condition? That we will see. Right? So well posed problem means a problem which has got a unique solution, and the solution will change its behavior continuously with the initial conditions. So what are initial conditions, that we will see. We will come back, right? Now let us see examples of well posed problems, because this is your first topic in the syllabus. We can expect this question also in your exam. Examples of well posed problems, right? Checkers game. It need not be checkers game, it can be a chess game also. Driverless car, house price prediction, right? Any other game, etc. Now, what we will try to do is, for example, driverless car. Let us take the example of driverless car, right? We are having three parameters as per the definition. Parameter 1 is experience, parameter 2 is training, parameter 3 is performance as per the definition, right? So training, experience and performance. Training, experience and performance. These are the three important words. Training, experience and performance. Training, experience and performance are three important words as per the definition. See here. A computer program is said to learn from experience E with respect to some class of task T and performance measure P, right? So please, in this particular example, right, every one of you might have heard this one, driverless car, right? Driverless car. Tesla has attempted, Tesla has attempted, even Google has attempted this, right? As of now, driverless car is not there in the market, but very soon you will see a driverless car also. Now tell me, if we are talking about driverless car, what should be the experience, what should be the training, and how do you measure performance? I want you people to respond. If I am trying to develop a machine learning model, if I am trying to develop a machine learning model, from where I will get the experience, a machine learning model for a driverless car. I mean, I am taking driverless car as an example. So if I want to apply machine learning to create a driverless car, what kind of experience the driverless car has to get, right? And what kind of training it will get, and how do you measure the performance? These are the three things, friends. Roads data to be provided. Okay. Roads data to be provided. 598 says roads data to be provided. It's okay, accepted. But friends, please tell me clearly, roads data to be provided comes under training or experience? It comes under training or experience? Everyone should respond. Everyone should understand the concept. It comes under experience. Okay. How many people think that road data comes under experience? Then what is training? If road data is experience, then what is training? (596) says road data is not experience, it is training. Objects that occur between road. Mhm. So friends, I'll fine. So here I have the experience part, then my training part, then performance. Right. See, we are trying to create or we are trying to develop a car, a driverless car, right? Autonomous, we call it as autonomous car. So training the data, from where it will get training data, it should be trained. The training data should be from the past experience, past drives, right? When a human has driven, for example, friends, I want to test this driverless car by testing it on a road from, let us say, from Hyderabad to Bangalore, right? NH7, I think. So it is around 600 kilometers. So what I'll do is I will try to get the training data from the different drivers who drove vehicles from Hyderabad to Bangalore. On NH7, 600 kilometers from Hyderabad to Bangalore, right? How many times I'm going to take a left turn, where I've taken a left turn, how many times I've taken a right turn, right? What was the average speed, right? What was the average speed, where I was getting some toll gates, etc., etc. So when a human being was driving a car from Hyderabad to Bangalore, right? So what was the average speed? What was the initial speed? How many times the vehicle has been stopped, right? And how many times left turn was taken? Where left turn was taken? Right turn, right? So maybe more information about the condition of the roads, like that. The training data I get from the people who have already driven the vehicle from Hyderabad to Bangalore, right? Now a driverless car has to work based on what? Based on vision sensors, right? A lot of sensors will be there in the car. The sensors will detect the objects, right? Sensors will generate lot of data. This data will be processed and a decision will be made whether to move forward, move left, move right, or whether to apply brake or whether to apply accelerator. That is experience. Experience means when you start involving in it, experience will come into picture. So friends, very simple definition. Experience means until unless you do it, it is not considered to be experience. So now this autonomous cars, they will have a lot of sensors, and sensors data will be processed, right? Sensors data is processed and decisions are made. And decisions are made. You please don't write anything. I will write. I will write everything, and I'll give you material, whether it is a soft copy or handwritten notes, that we will see. But I will definitely try to provide you notes. You please need not waste time in writing something. Please try to understand the concept. So sensors will be there. Sensors data is processed and decisions are made. And based on the decisions, the car will move, whether to move forward, left, right, all those things. Now, what do you mean by performance? What do you mean by performance? Can anybody define performance in this case? Can anybody define performance in this case? Performance. Accuracy in stopping or moving. Yeah. Very simple. Performance means, did you complete this 600 kilometers of the journey without any accident? Right? Very simple. Completion of the journey without any accident. Right? Completion of the journey without any accident or any type of failures. Right? Now, this experience, now for example, first time when this autonomous car failed, what do you mean by this? Whatever, either the problem was in the training or the problem was in the experience. Problem can be in both places, right? If your training itself is not correct, you can't expect a performance. Similarly, if training is good but experience, training experience, whatever experience you are getting on your own from these sensors, if this experience is also not correct, then the performance will be affected, right? So friends, such a big company, Tesla and Google, even they failed to attempt this project of autonomous cars. Of course, very in the near future, in very short period of time, we will be seeing autonomous cars in our country also. As of now, we can say it was not successful. So performance point of view, there were some issues and people are still working on it, but this is what is experience, training and performance. So for every problem, if we can define these three things, then they are called as well posed problems. And from these three words, we can also derive what are the design challenges or design issues, which is discussed in a separate concept called as designing a learning system. Designing a learning system is our next topic. Before we go to designing a learning system, we will take another example under well-posed problems, well-posed learning problems. The another example is house price prediction, right? Or you can take this checkers game or chess game, whatever it is. Right? Checkers game is also a game which is very much not very much, but to some extent it is similar to chess game, right? So there will be a board, and again there are some rules for the elements of the checker games. There will be a king in checkers game, right? There will be other pieces. So how to move, there are some rules. Just like chess game, there is another game called as checkers game, right? So let us assume whether it is checkers or chess, whatever it is, or chess game. Now suppose I want to develop a machine learning model, means I want my computer program to play chess and it should win, right? So just like the way humans can think and play the game, whether it is chess or checkers, similarly computer should also think. Computer should also make some intelligent moves. Computer should also learn how to play chess, and computer should also win the game. So it means that I want a computer to think like human. That is what is our fundamental concept of artificial intelligence, right? So here, machine learning is one form of AI. We all know that very well, and we are trying to apply machine learning. So when we are trying to apply machine learning to this gaming problem, now what is the experience, right? What is the training, and what is the performance? Right. So what is the training, what is the experience, what is the performance? In chess game or checkers game, again we try to define these three things. If we can define these three things, it's a well posed problem. So can I expect responses from your side? What is the experience? Yeah, people started responding. Is it going right way, right way or not? Okay, I think it's for car, it seems. Fine. So for chess game or checkers game, right? What will be the experience? What will be the training? And what will be the performance measure? Please think. Please respond. Come on, please respond. If it is a chess game, if it is a checkers game or chess game, what will be the experience? What will be the training? And what will be the performance measure? Please respond. Yes. 598, 596, 5E3. Task is playing chess. Okay. No, how a computer program or how a machine learning can straight away play a chess. Task is playing chess, but task we know. That's the reason we are not writing anything about a task. How to move objects is training. Yes, that's true. How to move objects is training. Right. So task we know very well. I am not worried about task. Task is let me write it completely. So task is playing the game. In previous example, task is driving a car. But what do you mean by training and experience, and how performance is measured? So friends, from where do I get training experience? Who will train me? Now there are two things. Experience I'll get into two methods. One is direct and indirect feedback, or you can say training. What do you mean by direct and indirect? Means direct means I will train my model. My model will let me write it direct. So model will learn by playing continuously with itself. I will play the game. I'll win. I will win. I'll play the game. I'll lose. I'll play the game again. I will lose. I'll play. I'll play. I'll play. I'll play continuously, and I try to learn from my mistakes. This is called as a direct method. This is the direct method of getting experience. Another one is indirect method. Indirect method. Indirect method means previously, right? When two human beings were playing the game, when two players were playing the game, what I will do is I will try to take the data from the people who have won the game, right? Suppose Mr. Anand, Vishwanathan Anand and Mr. X was playing the game. At the end, Mr. Vishwanathan Anand has won the game. So what I'll try to do is I'll try to get the data. Okay, what was his first move? What was his second move? Then what he has done. After that, what he has done. Like that, if I try to get the data from the previous games which were played by human beings, based on those strategies applied by the winner, right, I can also learn something. Similarly, I can also learn from the loser also, because I'll come to know what are the wrong steps I should not make. So the training data which I learn from others game played by humans, that is indirect method of getting experience, right? So if you closely observe, friends, training and experience both are very closely related, right? I train the model and model gets the experience. So training is nothing but if I feed, if uh, if I feed the past data of the game played by winners or players, that data can be used as experience. So training means what? Continuously giving the data, continuously feeding the data. So you train and model gets experience. So training and experience are closely related. Training produces experience. Training produces experience. So there are two ways, friends. One is direct and indirect. Indirect means already you have some data, right? Already you have some data and you try to feed it. That is called as indirect. Direct means you learn by your own experience, right? You learn by your own experience. Means we take the example of autonomous car. We don't take any experience of the past rides made by a human driver. Simply we will throw the car on the road and we will say you learn by your experience. It is very dangerous. It can create lot of accidents. So you can't say you learn by yourself. Continuously you go on road, make accidents, and you learn by your experience. That is not possible every time, right? Whereas if it is a game, I don't mind anything. Let my computer or let my computer program or machine learning model, let it improve by experience. I don't have any problem. There is no human loss or any risk in it. Let my program learn by itself. Let it play continuously, lose the game and lose the game, but you learn by experience. that is direct method. So please observe, direct and indirect methods are there. In some cases direct methods are used, in some cases indirect methods are used. Whether you use a direct method or indirect method, you are going to train the model. Training gives the experience to the model. Training gives experience to the model. And what is the performance measure in this case? Very simple. How many games the model has won? Very simple. So if my machine learning model, every time if it is failing the game, right, it means that it was not trained enough. It has not got enough experience, right? That's the reason it is failing. So performance measure means how many games the model has won, right? The, you can simply say the success rate. The success rate of the model, success rate of the model defines the performance. Success rate of the model defines the performance, right? Till this point, is it clear, friends? Design issues we will see in the next class, but before that, we will go back to that Excel sheet. We have to discuss one important point. But please tell me as of now, till this point, yeah, already some people told performance is games won against, yeah, that's great. That's true. Percent games won against opponent. Yeah, success rate is the performance measure. Fine. Till this point, is it clear to everyone? Please let me know. Till this point, is it clear to everyone? Kindly respond. Yes, clear. Fine. Thank you. Now, see here. Suppose, friends, suppose I say I have written a machine learning model, or I have created a machine learning model. My machine learning model will predict the weight. It will predict the weight for a given height. Suppose I made a statement like this, and you wanted to test my machine learning model. You gave an input. You gave an input like 6.11. Sir, if height is 6.11, what will be the weight? Just imagine I have executed my machine learning model, and my machine learning model told for 6.11 feet, the height will be, sorry, 6.11 feet height, the weight should be 87 kgs. Let us say my program gave this output. For 6.11, weight should be 87 kg. Now you will ask a question, sir, why should I trust your program? What is the guarantee that this answer 87 is correct? What is accuracy? How much accurate is your model? This question you may ask. Please try to understand, friends. You may ask me this question. How much accurate is your model? Right? This is a question you may ask. Then I should say, no, no, it is accurate. If I say, no, no, it is accurate, you will not accept me. I should talk in terms of percentages. 90% or 95% my model is accurate. Then it is up to you whether you accept my result, whether you consider my result or not. Right? So if height is 6.11, if height is 6.11, weight should be 87. Then you will ask, you asked me, sir, height is 6.11. I told weight should be 87. Then you will ask, sir, how much accurate is your model? then I should tell 95%, 96%, 97, like that. But how do I calculate this performance measure? How do I calculate this performance measure? This is important, friends. So what we will do is, in general, what we will do is, first of all, we have the data, no? Let us say for these 10 combinations, I got the data from a doctor. So I already have input and output, data and output for 10 cases. I have data and output for 10 cases. So what I will do is, this is very important point. Please listen. When I train the model, I will not give all 10 inputs. I will give only 1, 2, 3, 4, 5, 6, 7, maybe like this. I will give only 70% or 75% of data for training. I will not feed all these things, my dear friends. I will give only this much. I'll not feed everything. I will not feed everything. Now y equal to mx plus li, to this function, to my machine learning model, I will not give all my 100% data. I will give either 70% or 75% of training data. Means whatever data I have for training, I will use only 70 or 75%. Remaining 25% will be used for testing. Remaining, if it is 70, then the remaining will be 30%. Or if it is 75, remaining is 25. 25% for testing. So what do you mean by this? What I will do is, I will create a machine learning model. I'll create a machine learning model, and for this machine learning model, I will give these 70% of data for training. Now the machine learning model is ready. After that, I will test, because for this I know for 6.2 what is the weight, 77. Now what I will do is, this is the weight, this answer I already know. Now what I will do, I'll test. So if input is 6.2, what my program has given, let us assume program has given 80. For 3.5 feet, my program has given answer as 48. For 4.9, my program has given answer as 60. See here. So this is testing, friends. So entire data we will not use for training. 70% we will use for training. 30% or 25% I will use it for testing. Because how do I know whether the model is working properly or not? I will test it on the data for which I know the answers also. So for height is 6.2, I know that weight should be 77. Then I will see what my model is telling. So please observe this. So height is 6.2, right? This is my test data, and this is my test data's actual output, right? And this is the output generated. This is the output generated. This is the output generated. So there is a difference, right? Actually it should be 77, but I got 80. 44, I got 48. 56, I got 60. In all three cases it is different. Then how much it is different, that variation will be calculated. Suppose I got here 56. Here I got 44.5. Here I got 76. It should be 77, I got 76. It should be 44, I got 44.5. It should be 56, I got 56. So like that, on the test data, I have two things. What is the expected value? This is expected value, my dear friends, and this is generated value or actual value which I got. So what I'll do is, I will try to understand what is the difference, right, between expected value and generated value. This variation can be calculated. How much percentage of variation is there? How much it is close? The generated value is close to expected value or not? How much close it is? Based on that, we can calculate the performance, right? Or else, in another way, I can define the performance. Out of 3 cases, how many times I got correct answer? Exactly correct answer. I got only 1 time correct answer. So performance is only 1/3. 1/3 means 30%. Only 30%. So suppose if I got, let us say, 44 here, here 56. Only in one case it is not same. So out of 3 test cases, 2 times it was correct. So 2/3, 2/3 into 100 means 66% will be accuracy. Like that we can calculate the performance measure. Like that we estimate the performance measure. So I hope you got some basic idea of what do you mean by performance measure, right? What is expected, what is generated, how close the generated value is with expected value, that is performance measure, right? And in future we will see how to improve this performance. That we will discuss over a period of time in our subsequent chapters. So till this point, is it clear? If it is clear, tomorrow we will discuss design issues, right, which is very important topic. Till this point, is it clear? Please let me know. Please let me know in the chat box. Right, that's great. Okay, friends. So in the next class, we will see the design issues of a learning system, which is very important question, which can be expected in both mid-exam as well as external exam. So that's all from my side for today. Thank you. Thank you very much.